NOx is the other side of the emission world. That means that most of the industrial or stationary or automotive and marine sources are giving a NOx emission. NOx, it's an important issue to be investigated today. Of course, marine represent 1/3, as you can see on the slide, 1/3 of the global NOx emission. The other two big portions of this are the public electricity generation, so the power plants, and the automotive. Differently by the automotive and by the power industry or by the other combustion sources, marine is an industrial sector that has been not affected at the moment so much by stringent legislation on NOx removal. That means it's the next target for the operators, for the suppliers, for the IMO, of course, to take care about environmental impact by the ships. These numbers are based on an old emission inventory that's 2011. In fact, you can see that SO2 was still a big portion in terms of marine contribution to the global. Now is going, of course, lower due to and thanks to the scrubbers that our other presenters spoke about before. NOx is still a very important portion in terms of NOx emission from marine industry. Another important issue to be considered is that 70% of the global traffic is sailing closer than 200 miles of land. That means that the impact of this emission, of NOx emission from any kind of vessel, is very strong, close to the land. That means that it's important to drive this kind of new legislation in order to prevent, as much as we can, the impact of the environmental, the impact of the NOx emission on the environmental area where all of us are living. Just to give you some very simple numbers to let you understand the importance of the NOx emission in the world. One giant cargo ship emits a quantity of nitrogen oxide, so of NOx, that is more or less, of course, equivalent to 7 million passenger cars. It means, for example, that also a cruise ship visiting a single port on a day, they emit the same quantity that is emitted by 12,400 cars in a point. It's like having a meeting of 12,400 cars at the same time at the same point. And in terms of global emission, just to think about that, 100 big cargo ships may contribute to NOx emission as much as the today, of course, entire global car park. That means 750 million cars. This is because automotive has already issued a lot of stringent regulation. Marine didn't in the past, and it's still, of course, evaluating the same thing in order to reduce these kind of numbers, in order to avoid this kind of NOx impact on a port or anyhow close to the land. Just also think about the future. We expect 20% rise on this kind of emission from the ships in the next 5 years due to the global shipping activity increase, mainly, of course, cruises that are going up in terms of number of vessels and number of routes and so on, not maybe on the bulk and carrier and tankers and so on. And due to this increase, we have to think about that marine should give a sort of solution to that. Marine industry should give a solution to that, because it's the same solution has been given already, both for the inland industry, so the combustion sources like the power plants, the waste incineration, the stationary engines, and so on, and also by the automotive sector. In both cases, simply due to more stringent regulation. What's the status today in terms of regulation? IMO issued in the past a different type of NOx reduction legislation, starting from tier 1 in the 2000. You can see the different efficiency in terms of NOx removal or the different emission factors. Tier 2, again, was issued for new ships in 2011, and it's now covering the majority of the ships. Tier 3, that's the next actual step, will be affecting the new ships starting on 2016, but only in the famous and so-called emission control areas, so designated areas. And there is still a discussion whether this 2016 can be eventually even more delayed for some specific region. You can see that there is a big gap between tier 2 and tier 3 in terms of NOx reduction. So from tier 1, if we go to tier 3, we have to think about an 80% NOx reduction, independently, more or less, by the rated engine speed. That means that is a big step. These are the actual, under IMO regulation and discussion, actual emission control areas. So North America and Caribbean, and in Europe, more or less Baltic and North Sea. There are trends and there are discussion about the future introduction of new ECA, and like, of course, the Mediterranean, like Japan, all the Japanese coast, like north of Norway. All these are, in any case, under discussion, and as we said before, that nobody knows what would be the trend of the fuel price in the future, we can say the same probably for NOx emission. Nobody knows when IMO will issue new legislation or new emission control areas in the future. The only, I would say, clear answer is that sooner or later we will have the need to put NOx control on different or on a greater amount of vessel than today. We provide a simple solution. We provide a solution that is a consolidated technology. It's not the only one, as you can listen to the next presentation, but it's a consolidated technology that has been applied since 1960, so almost more than 50 years, in all the other industrial sectors, starting on power plants, going through waste incineration, going through stationary engines, cement plants, glass plants. So all the other industrial sectors have been already equipped with this kind of solution. The technology was invented by Japanese people, so by Mitsubishi, more or less, in the 60s. It's a very consolidated technology, very simple technology, and effective. Our solution that we named Micro, in order to provide you a simple understanding about the footprint of our system, is based, therefore, on the so-called selective catalytic reduction, so SCR process, that would remove 90% of the nitrogen oxides from the different ship engines, either propulsion, auxiliary, pump, and so on. Enabling, therefore, to comply with the famous and previously mentioned IMO Tier III NOx emission levels for the ships operating in the NOx emission control areas as governed by the regulation. So Airlife Microsystem is a very simple product and has been applied before the marine industry on several projects on different industrial sectors like engines, waste incineration, power plants, and so on. How it works, as we say, is very, very consolidated, is very simple. The flue gas coming from the engines, whatever is the fuel and whatever is the type of the engine on the ship, goes through a catalyst. The catalyst is based on vanadium pentoxide as an active element, is a ceramic catalyst, and NOx, thanks to the catalyst, is converted to nitrogen and water vapor, so very safe and harmful components that can be can be released to the atmosphere. This process would be effective using a urea-based reagent that is simply a urea solution, a urea water solution on a certain concentration. In stationary plants, we use also ammonia water solution because it's a little bit simple in terms of control of the process, in terms of dosing and so on. In terms of arrangement on board, so how it works in the ship, the SCR can be installed, of course, between the engine and the funnel or the stack in a location that would have the proper temperature. That means that compared to the location of the scrubber, we need to stay closer to the engine because we need a certain flue gas temperature, something like 250 to 350 degrees C. It's a modular solution, so depending on the engine size and the NOx reduction requirements. And it's a specific tailor-made solution every time to match the specific layout, the available space of the engine rooms. Either we talk about new builds, a new vessel, or to retrofit existing ships. As Marco said before, also for the NOx, for the DENOX system, it's important in order to save installation cost to have the idea to foresee in advance the potential presence of the DENOX later on. That means that if we think about to put a DENOX-ready vessel, it may save a lot of installation cost instead of retrofitting the ships later on, just to leave the space for this installation. The benefits of our system, it has a very long catalyst lifetime. Catalyst is the most important element and it's also the most expensive one. And to have long catalyst lifetime means that I would say that the cost for maintenance is greatly reduced. We can also offer a special catalyst regeneration after a certain time that would give additional lifetime to the catalyst without needing to replace it. Very high emission removal, more than 90%, as we say. Low ammonia slip, very low. Ammonia is the byproduct coming at the stack after the treatment. The SCR reactor is working as a small, in brackets, silencer, depending on different noise levels and noise type of waves, resistant to vibration, of course. Very small micro, so very small footprint on the layout, flexible installation, whatever would be the type of the ship and the type of the engines. We can also remove other pollutants like CO and a little bit of dust as well. Only operational cost by urea consumption because the power consumption is very low. Compatibility, we can design the system to require any kind of NOx removal efficiency on the worst engine case and load condition and worst fuel. We are, of course, able to design something that is compatible with the scrubber. Means that the SCR is installed before the scrubber, simply for a catalyst temperature issue. We don't need a bypass, because there is no need to have a bypass installed on the SCR reactor. I'm here and I'm happy to reply to any kind of question later on. Thank you very much.